Uh, so, hi, Steve.
Hey, Sam.
Uh, so, we do have an agenda with some questions, but I don't know if you have any presentations or demos to just give a background about Cyclone DX and why there have been lots of recent conversations um, around the importance of SBOM and why it suddenly shot up in popularity.
Certainly, I don't have a presentation, but I can talk a little bit about the background, why it exists, what problems it solves, and really, I'm here for all of you and to answer any questions that you have regarding the specification, regarding SBOMs in general, what the various formats are good at, what they're not good at, what the gaps are. So use me as a resource. Um, but with that, I'll just go through some history on why it exists and what problems it solves, if that's okay.
Yeah, that would be helpful. Thanks.
Certainly. So the project that I was working on was OWASP Dependency Track. It's a currently it's a flagship project. It was started in 2013 around this notion of component inventory. So we're not talking about SCA. That the problem I had back in 2013 was we were shipping server appliances at the time. My employer was. These were rack mountable things that went into data centers. We would probably refer to them as antiques by now, but they were, a combination of hardware and the entire software stack, everything from the firmware to the drivers to the operating system to the application to the libraries. We needed to track the entire thing. And there wasn't a solution that really did that at that time. And Dependency Track, I started that project as kind of a way to do that. And it worked for the use cases that it was intended for at the time. But, that concept started gaining a little bit of momentum in the security space, right? Having that portable inventory of stuff. And it wasn't until 2017 where the dependency track project really started to look heavily into, we just call them bombs or bill of materials. So that's what we refer them to, and everybody else in the community refers to them as S bombs. We specifically do not refer them to them as software bill of materials because the format can actually handle things other than just software components. So that's, I guess, to be noted. Anyway, in 2017, I was looking around at viable options, and the only thing that I could find at the time was SPDX, and it was doing some really great things for license IDs and license expressions and all that sort of thing, but it didn't meet any of my security requirements. So it was overly complicated. It was very flexible in how it could actually do things, which actually led to huge amounts of problems when it came to automation. So the security space, we're all about automation just because we have a lack of resources for the most part. Everybody in this space is already employed. Um, so having something that was highly automatable um, and was simple was kind of a requirement, as well as having the available tooling and ecosystem support to be able to have a widespread adoption. And in 2017, I looked at SPDX and I'm like, oh, this is not it. So I looked around for some other things and I just didn't find anything. So not that I went out and this was my desire to create a new specification, but unfortunately, that's the way the world was in 2017. Nothing else existed that met my requirements. My requirements were very simple and are founded by a lot of the stuff I learned in physical supply chains back in 2008 when I was doing supply chain security for pharmaceuticals. Specifically, this standard called ePedigree. It's an EPC global standard that tracked the manufacturing and distribution and wholesaling of pharmaceuticals, from manufacturing to your shelves at your local CVS or Walgreens. And there was a few things that I learned while doing physical supply chain things in 2008. One is that if you have a very simple model, you can very easily get high degrees of automation without much effort. And number two, if you have a simple model, you get mass adoption relatively easily. So I learned a lot of things with regard to that spec, and I kind of applied them to Cyclone DX in its initial version. So Cyclone DX is, if you look at it and you compare it to SPDX, they are night and day, right? These standards look entirely different. And that is by design. One, we needed in the security community, we needed people to adopt this, right? We needed the ability for any individual contributor or any security organization to be able to spend as little resources as possible and create a fully 100% compliant version of the spec with minimal amount of effort. So that goes back to the very simple model. Two, we're in the security community, and we're dealing with continuous integration and delivery pipelines all day long. And one of the things that we wanted to be able to achieve with a software bill of material is not just the creation of it. That's easy. Anybody can do that. It's the, once you actually have it and it's being passed on throughout your build pipeline, how do you automate the augmentation and correction and modification of that SBOM throughout your build pipeline using a bunch of different tools to do that, so that your end result is this uber enhanced thing that, yeah, it has what you started out with, but now it's got all this enriched data in it. So having a really simple model is actually key to being able to do that. And what we found is that we had a lot of adoption pretty much right away. So the spec was essentially created in 2017. The first version is in, I think, like March 2018. And I don't know how many tools we support right now, but it's upwards of 60 tools that actually support the standard that we know of. I know there's more than that, because I know there's other organizations that have built their own tools and haven't necessarily created a commercial product around them or have open sourced them yet. But it currently has the largest tooling ecosystem of all the formats. We support pretty much every build environment you can imagine. Everything from CocoaPods to Java to NPM to Golang. And for some of these ecosystems like Golang, there's multiple options, right? There's not just one, there's like 3 or 4 that you can actually choose from. So there's a lot of choice in the ecosystem. In Cyclone DX, the model is fairly simple. Everything is a component, right? You can have file components, you can have library or framework components, you can have container components, operating system components. Basically, everything is a component. And CocoaPods, right on. And so with that regard, it's really simple to do. However, software is not confined to a single machine, right? I don't know if I even own software that doesn't call out to some service somewhere, right? It's going to be very difficult to find any kind of software that is specific to a local machine and doesn't make remote calls somewhere. So Cyclone DX, a couple of years ago, we created the concept of a service as well. Again, we're in the security space. And so now services are now part of the model. And what this allows us to do is capture dependency graphs. For example, if I have an application and I have a list of my dependencies and whatnot, and maybe I have a dependency, maybe it was auto-generated code from a Swagger doc, right? But that library that I have, it doesn't actually do anything. It just makes these remote function calls somewhere. So actually, I can actually describe that kind of relationship with Cyclone DX today. The other thing that I learned very early on is that, and I used to work for an organization that we had three-letter agencies as customers. So we were getting audited all the time from, various folks that, anyway, um, one thing that I learned early on is that when you communicate the inventory of your components, um, you're not providing all the context. So Cyclone DX, and this kind of goes into the whole open source thing, right? Open source is the ultimate supply chain, right? Components are modified and forked and renamed and rebranded and redistributed all the time. And Cyclone DX actually has adopted that kind of model. So you can actually describe a component's pedigree, where its derivatives were from, what the specific modifications that you have made to a component to make something unique. And this is really important because most SCA tools today, software composition analysis tools, they have no idea about any of that information, really. They basically just try to fuzzy match on, hey, I think this is component X because it has this kind of evidence. And that's really as far as they go. But if you are truly embracing SBOMs as part of the way you build software, you can actually describe what those changes and modifications were. My employer, we own about 300 open source projects today. Not that we want to, but these are things that we've forked and we've modified. And we need a way to communicate what those things were. And in many cases, and this goes back to context, in many cases, we need to communicate what we fixed. Because when you communicate inventory, you are inevitably going to get a lot of questions on, hey, you're using this vulnerable version of jQuery, right? Actually, no, I'm not. I'm using this older version because I can't upgrade because of API changes, but I've actually backported these fixes. So there's your additional context. And you can actually describe a lot of different security use cases with Cyclone DX today. I think there's about a dozen or so security use cases that that the spec fully supports. So with that, I know I've rambled on for a little bit. So with that, I'll take some questions.
I have a really basic question to start. So the use case we're looking at for Cyclone DX is to describe the contents of a container image. I think we also maybe have an idea that we need to describe the tools that were used to build the container image, kind of separately from what's actually, what's the software that is included in this artifact, right? What, have you seen other uses of Cyclone DX to describe container images? Can you talk about pitfalls of doing that? Other folks who have been successful at, applying Cyclone DX in that context? Because I think before we talk about like Buildpacks specific use cases for it, now Buildpacks might use, have a process of, creating a software bill of materials, for that image, just understanding at the level of container images, right? Would be helpful for us.
Sure. Yeah, I don't think there's, in terms of containers are interesting. Obviously fully supported in Cyclone. I've seen a number of different ways that various companies have created their SBOMs for container images. Cyclone DX is pretty prescriptive in how you do things. So it's much less flexible than something like SPDX. but that's by design, right? So there's just a lot less possibility to shoot yourself in the foot. Um, but I think there's a number of different ways that you can approach container images. There is a component type called container, right? So within that container, then you can then have a nested set of other components. For example, if you wanted to have nest branches basically for each of your layers, for example, that's entirely possible. Or if you don't want to represent layers, that's possible too. I think there's a number of different ways to do it and still communicate the fact that this is a container and you may or may not necessarily be representing the various layers within there. And then within each layer, you can obviously describe the files and that sort of thing that's in each layer.
I think that's really helpful for that first software bill of materials. It's like this is the contents of the container in the end. The layering is especially useful for us because unlike a Docker file, our layers are very contractual. They each have a set grouping of software in them. But the I think we also want to capture the tools that are used to build the image that may not end up in it, right? And sometimes that line is blurry, like, oh, a compiler actually puts a runtime in your binary, right? Sometimes, but sometimes it's very clear, like you used curl and it was this version of curl to download something, and it's definitely not related to the image you generated in the end. Does CycloneDX have ways of representing that type of data? Do people usually combine that data together, or do they keep it with the description of what's in the artifact? Do they keep it separate?
There's a couple of different ways that you can do that. CycloneDX was created to be extensible from day one. So basically, the validation of Cyclone involves XSDs or JSON schema, right? That's it. Of course, we have tools to help you validate that, but it's fairly simple to validate. But for XML, JSON's a special case because it's not extensible in the same way that XML is. But for XML, it's actually quite easy, right? There's many organizations or industry verticals that have actually created their own extensions that actually sit on top of CycloneDX to give it additional functionality, right? That same capability can exist in JSON. It's just really ugly, and it's just, yeah, it's not pretty, but it can be done. So most of the organizations that have extended it use XML just because it's easier. However, there's a couple of different ways that I've seen other organizations use that kind of data. Lockheed Martin, for example, adopted it, I don't know, a couple of years ago. And they were actually using a custom version of Cyclone that they were using. And their modifications essentially have been integrated into the core spec as of version 1.3. We now support properties, and these are just name value pairs. So you can actually put just random data in these name value pairs to describe some of the, very specific element types that you might have, right? That may not necessarily fit anywhere else. The other option is, like I said, CycloneDX is meant to be extensible. And one of the things that we are experimenting with is the concept of, I'm at a loss for words now. It is, a formulation extension. And formulation is really the concept of what were the parallel and sequential build steps that were undertaken to create the artifact that I'm representing in the SBOM. So that's some work that the working group is actually working on. And if you like to contribute to that kind of thing, we would love to have you.
It definitely sounds interesting. It would be great if you could send a link.
Sure.
I'm to see if other folks had questions, but I think we do have a couple things on the agenda also.
Yeah. So I think the main reason why like this whole conversation started is Buildpacks currently do have like some support for bill of materials in the sense that we allow authors to generate one the during container building itself, which is sort of unique and different from Docker. Um, but it's not structured. So we were looking at different formats to sort of structure the data we are putting in there so that it's easy to use for like scanning tools further on in the pipeline. I think like one of the questions that I'm interested in is like uh, there seems to be like this NTIA working group comparing different formats and like trying to figure out which one, like what kind of gaps and holes each one has. So can you, and I also saw you were involved in discussions there representing the Cyclone DX side. I don't know if you have any
Certainly.
thoughts on like what Cyclone DX shines at and what SPDX does better apart from what you already mentioned around flexibility. Is there anything else that um,
Certainly, yeah, and there are some cases where SPDX truly shines. It's had a lot of um, history in the license and intellectual property space because that's where it started from. So things like snippets, for example, only available in SPDX. Now we can debate whether or not snippets actually belong in an SBOM. They may not, but that's something that SPDX supports. There's a lot of other smaller license and intellectual property attributes that SPDX supports as well that is not present in Cyclone. What you will find is that there's a lot of, again, this goes back to the flexibility. There's a lot of, um, of, of things that different ways to represent things in SPDX. And what you'll find is that Cyclone is just the opposite. It's very prescriptive in how you do things. And that's by design. Again, going toward the automation, being easily adoptable, etc. But if you look at the core capabilities, what can the specs actually do today? And what, even with SPDX3, what can they do tomorrow? You will find that Cyclone DX has more capabilities than SPDX does today, especially with software security use cases. The easy case is, hey, I've got this component and it has known vulnerabilities, right? Anything can do that. A spreadsheet can do that. But there's a dozen other software security use cases that that Cyclone DX supports today, in which there's some really interesting commercial investments that are happening in this area. I mentioned services before. This is some really interesting stuff. There's actually organizations using SBOMs today as a baseline, and they're actually measuring the telemetry information from applications at runtime to see if there's any variance in what the SBOM actually describes, which is versus what the application actually does, and looking for anomalies. So when you're looking at supply chain as a concern, Cyclone DX it doesn't handle everything, but it handles a large number of software security use cases today. So if you look at the capabilities, it will become apparent which one is better at security use cases. Does that answer your question?
Yeah, so I'm guessing Cyclone DX, because it's prescriptive and it has extension points, it can describe all of these like various different supply chain issues that you described, whereas SPDX is more for compliance use cases where you want to find out license information and
Right.
okay.
And Cyclone DX actually, just the last point here, the DX after Cyclone is actually an homage to SPDX. When we set out to create a spec, we did not want to reinvent the wheel. SPDX license IDs and expressions, they're everywhere. We're not going to reinvent that. So we reuse them. So Cyclone supports SPDX license IDs, it supports license expressions and copyrights and a lot of other licensed use cases. But that's definitely an area where if that's your focus, that's where SPDX shines.
I think the other question we had was around like the different package locators or coordinates that uh, both of these ecosystems use. So there's SWIT tags, there's PRL or Perl, and there's CPE. Uh, like a lot of us here, I don't know about others, but I personally am not very much familiar with uh, what's best among all three of these or things, or which tools uh, use which format. Can you uh, talk us through a bit about like what these different formats do and how they're actually used like downstream for scanning?
Certainly. So there's three different common ways, I guess, to identify software. One is package URL. This is anything that is going to be either using a package manager or is stored in a repo somewhere. RPMs, for example, could be represented using package URL. And then there's CPEs, which is primarily used by the NVD, but it's also used elsewhere. And then there's SWID tag IDs. All three of these things are used to identify software. Perl, or package URL, also being able to not only identify the software, but actually being part of the provenance as well. Where did you actually get this piece of software from? So Perl actually handles both of those use cases. The other two just are merely identity. All three of those can be used in software security use cases today. Perl, package URL, being the most widely used. So most SCA vendors, they have their own internal databases of this component is vulnerable to this thing. Most SCA vendors don't actually use CPEs natively. What they actually do is they actually have a mapping between the open source components and the vulnerabilities. And if the vulnerability is in the National Vulnerability Database, that's how CPEs are derived. But they don't typically use CPEs natively because CPE is not capable of representing modular components. So it's only capable of representing vendor name and version. That's it. So things like Spring Framework, where there's 30 different submodules, you can't represent that in CPEs today. You can represent that in package URL. So you'll find that most of the vulnerability databases out there outside of the NVD don't actually use CPEs natively. It doesn't give them the detail that's necessary. But the NVD is adopting SWID. Everybody is kind of waiting for the transition plan. CPE is deprecated according to the NVD folks. I haven't seen any public documentation on the fact that CPE is deprecated. However, from the mouths of the NVD folks, it's been communicated multiple times. SWID is their replacement. They have REST endpoints on the NVD today that actually support SWID. And I've been talking, the Cyclone DX Core Working Group has been talking with the folks over at NIST for a while now. And there's some shared efforts that we're going forth with regard to Cyclone DX and SWID, because SWID is actually natively supported in Cyclone DX today.
One thing I've noticed about Perl, like compared to CPE, with CPE, I can, query for all OpenJDK CVEs, or OpenJDK CVEs that match some portion of a CPE, but not others with wildcards. I haven't found a way people are using Perl that way. Do you have, if we kind of lean towards Perl for identifying software packages, but need it to refer to this Ubuntu package, but not the specific version of it? Is there a way people are using Perl that way that you've observed with Cyclone, or outside of Cyclone?
Yeah, so Perl, it's going to represent, you can't really do wildcards today in Perl. There is a proposal to support version ranges. So that might actually come. And that would actually solve a lot of the verbosity that might exist. So you won't have to describe 1,000 different CPEs. You could have a much shorter list to describe all the various ranges of things that are potentially affected. So if version ranges actually come to see Perl, then that would probably be the best way forward. Most of the use of Perl that I've seen is with regard to OSS index from Sonatype. Now it's called Sonatype Lift, I think. But they basically have mappings between all the various package URLs and vulnerabilities, whether it's something in the NVD versus something that Sonatype themselves know about, etc. So that's yeah. Until version ranges are supported, I think your databases are going to be overly verbose.
And how does SWID handle this if it does?
What's that?
How does SWID come into play with this? Like you said, that CPE is being deprecated in favor of SWID. So, uh, like, how does SWID handle these kind of things?
That is still to be determined. I've had ongoing conversations with Dave Waltemeyer over at NIST, and we're still waiting for, outside of NIST 8060, we're still waiting for guidance, what the NVD is actually going to do. I have a few concerns over their approach. And it's quite possible that the continued relevance of the NVD might continue to erode over time. And by that, I mean that if CPE, and they don't have a SWID answer yet, but if they are not able to represent the majority of software today, which they can, which they cannot, then you're going to see, in my opinion, you're going to see a lot of new sources of vulnerability intelligence emerge as competitors, essentially, to the NVD. You already see that in the commercial space, like VulnDB from Risk-Based Security. They support CPEs today. They also support package URLs. Any viable vulnerability database actually needs to support all three methods of identifying software, because software can be identified a lot of different ways. And if you only support a mechanism to identify software in one way, you're limiting the number of use cases and the amount of software that you're actually able to describe. So we're still waiting for guidance, though, but we'll see.
I had a follow-up question on that. So currently, Cyclone DX only allows a single CPE tag or component. I'm not sure what it's called. Whereas, like some of the tools like Sift output like a list of them, and I think SPDX also supports like a list of external references, and each external reference can be like a, sorry, I may be missing the specification, but it can support a list of either package URLs or CPEs. So is there any specific reason why Cyclone DX only allows one, and that's also marked as deprecated?
Technically, you only have one. The reason why you would support multiples is because of data inconsistency issues in the NVD. So if you're using the NVD as your only source of vulnerability intelligence, actually having more than one CPE makes sense. In reality, however, that component is only going to have a single CPE. For external references, one of the things that you can do with Cyclone, for example, and you've been able to do this for, I don't know, the last couple of years or so, but every component can have external references, and our external references are a lot different than SPDX's. Identity is not an external reference in Cyclone DX. It's part of a component's identity. So it's not something external to the component. But with Cyclone, you can actually link out to security advisories. So if you have a CSRF or CSAF or some other kind of security advisory feed, you can actually say, hey, I've got this component, and this is where you can find the advisories for that component. So you don't necessarily have to use package URL, CPE, or SWID to actually do that. You can just say, hey, here's where the advisories for that component actually live.
Oh, sorry.
Go ahead.
Okay. I have a question kind of going back to the different available formats for describing software bill of materials or bill of materials. Cloud native build packs is adopted on kind of most major cloud platforms at this point. If we commit to choosing a particular format and make it create a dependency both on the kind of provider side, people writing the build tools, and on the consumer side, people looking at images and getting software bill of materials off of them. It's kind of a large commitment for a lot of people. There's kind of risk associated with that. And we're also aware that the space is changing a lot, right? SPDX is looking at adding more functionality. The Cyclone DX definitely isn't the only tool that tries to capture some information, although we like that it's very security focused, right? And there's lots of real tools that work with it right now. Would you recommend kind of betting on Cyclone as the thing that we could stick with for a long time that would provide that kind of functionality for security scanners to understand what's in images, and also have people be able to take that format and use it as a general software bill of materials format for other use cases too.
Yeah. So yeah, Cyclone, I mean, I would, we're going to live in just like we live in a polyglot language environment, we're going to live in a polyglot bomb environment. That's just the reality, right? Imagine a world where we only had one programming language to choose from. That would really suck. And you pick a language and you find things that you like about it, whether maybe you like static typing over dynamic typing, right? Or maybe you like dynamic languages or whatever. So there's use cases for all of these things, and they're all going to be viable. The one thing that Cyclone DX has is the design, right? It's prescriptive and it's highly automatable. SPDX, with version 3 anyway, obviously they're introducing some breaking changes, and those breaking changes are very, very necessary because version 2.x is kind of broke in my opinion. So I'm glad they're actually breaking SPDX because they need to. I'm not convinced that they've actually figured out security profiles and vulnerability profiles and all this stuff yet. They're still trying to, well, I won't speak for SPDX, but I think what you'll find is that there's already a lot of adoption in the security community for Cyclone DX. The momentum is already there. Trying to come into the security space with a lot of folks doing license and intellectual property, kind of leading that effort, might have mixed results. Recently, Cyclone DX joined the OWASP Foundation as a flagship standards project. OWASP actually had to create a new category of projects specifically for Cyclone DX. Previously, they only supported documentation, tools, and code projects. So now there's standards projects within OWASP. So because of the OWASP connection and all the security vendors supporting OWASP, I think you're going to see the adoption escalate even more than it has already. I know of a handful of SCA vendors that are like almost complete with their implementation of Cyclone already. So you're going to see many more announcements in the coming months for various commercial providers that support it. You're also going to see, I think, some innovation in this space as well. the more one of the formats stretches the boundaries of what's possible, those are the things that kind of lead toward innovation. And keep in mind, this space that we now refer to as software bill of materials, this is actually over the last decade. This was a market that essentially failed, right? And if it wasn't for the efforts of NTIA, would mostly still be failing, although you'd still have a lot of folks adopting this in the security community. But it would, for the most part, still be a failed market. But I think the SBOM formats, especially the ones that push the bounds, are really going to be sparking some innovation. I mentioned some of the work that's being done by a few different commercial vendors to, for doing the services support in Cyclone, right? Where you're actually monitoring an active application and using the SBOM as baseline, et cetera, incorporating the data classifications, the directional flow of data, trust boundary traversals, et cetera. I think you're going to see a lot more of that kind of innovation in the future. For example, how do we automatically identify services in our components today? There's no way to do this, right? SCA vendors have had the last decade to figure it out. They haven't, because nobody was asking for it. So it's specs like Cyclone that are pushing the bounds and trying to make things happen that I think hopefully will kind of spark some of this innovation in the security space, because it's truly we desperately need it.
Um, Thanks for that. I had a couple of questions on like um, conversion between different SBOM formats. As you said, like uh, this is gonna be a poly SBOM market. So there might be tools that, let's say, only support SPDX or Squid or something else. Um, can you speak a bit more about like conversion between the two formats? Because there are obviously fields that exist only in Cyclone DX and cannot be mapped to SPDX and vice versa. So how
Yeah.
does, like, what kind of information is typically preserved? Is there some sort of convention between the field mappings across the different formats? And I see that
Yeah.
Cyclone DX already sort of supports some conversion, but I'm just curious to know some thoughts on that.
Certainly. So we talked about capabilities earlier, right? And SPDX being more flexible and has more options to represent data in different ways. Cyclone being more prescriptive, less flexibility. What you will find is that the capabilities, if there's a one-to-one mapping between the capabilities, there's a lot of easy wins that we can do for conversion. So we recognize, the security industry recognizes that security is only one of the seats at the table. It just happens to be the one that gets, boardroom discussions most of the time. License, not so much. But we recognize that lawyers also have to use this stuff. And so with Cyclone, because we have more capabilities than SPDX does today, we're actually very easily able to actually generate SPDX 2.1 and 2.2 documents today from existing Cyclone DX documents. It's fairly elementary. The only thing that we can't really do, because the spec doesn't support it, is snippets, right? And I don't even know if we ever will support snippets. Talked about that. But all your component information, your license information, copyright information, external references, all that kind of information you can start off with Cyclone. And if you have lawyers, legacy systems, whatever that need SPDX, we can generate that, no problem. Going back the other way, however, going from SPDX to Cyclone DX, You can also do it. Again, you're going to lose the snippets. So if you start out with SPDX, you're going to lose snippets when you go to Cyclone, unless you actually have a schema extension for Cyclone that actually supports it. So you will lose snippets, but everything else will pretty much be field to field mapped. Once you get outside of the package or the component in Cyclone, you start to get into just great differences in concepts, right? And that's when the field to field mapping approach breaks down, because how can I map a commit for a pedigree, a modified component? How can I map that piece of code over to SPDX? I have no idea, because the concepts are entirely different. So once you actually get outside of that base thing, it becomes a much more difficult to do the conversions. But yeah, with Cyclone DX CLI, which is our command line interface, you can output SPDX 2.1 and 2.2 from any Cyclone DX 1.2 or 1.3 document.
I think one other question I had was around merging different Cyclone DX documents. So as we said, currently Buildpacks are these individual units that come together to build a final container image. And these individual units currently are in charge of providing their own SBOM representation, and we as a project are responsible for merging them together. So what kind of merge strategies does Cyclone DX support, and like, is there a predefined one for containers when it comes to layers, or do you have any thoughts on that?
Yeah, right now the tools support merging of SBOMs. This is a fairly common use case, actually. Most applications are polyglot. You've got maybe Java or Ruby or Python or something on the back end, and you might have a JavaScript front end. You want to create a single SBOM to represent your application as a whole. So you take the SBOM from the Python, you take the SBOM from the JavaScript, and you merge them together into one BOM that actually represents reality. That's a very common use case. The Cyclone DX CLI does that today. Where there's some room for improvement is to be able to define where in the SBOM you actually want to merge, right? So right now we just merge at that top level, right? But in reality, what we would want to do, and what the spec is capable of doing, is maybe you have a component which includes other component. That's kind of a nested assembly in Cyclone DX. So what we would like to do is be able to take a supplier's SBOM, for example. Maybe I'm creating a piece of software, but I have another supplier. I want to be able to take their SBOM and put that into a single component in my SBOM, have their nested assembly actually signed by them, and then I will sign the SBOM in its entirety. So you can have a lot of flexibility with regard to what parts of the SBOM you actually want to sign and what parts you don't. But I think there's some ways that we can improve where in the SBOM you want actually your component inventory to go. And that's just a tool tweak. That's nothing with the spec.
I think one other question that's come up is the format we should be storing things in. Currently, the project extensively uses TOML to describe metadata, and like from your description, it looks like XML seems to be a more extensible format. And is it also a more complete way of representing Cyclone DX SBOMs, or is there some information lost when you move from XML to JSON, for example?
There's no information lost. However, if you're using schema extensions, again, JSON is not extensible, right? It's not. If you actually want to harden the JSON schema, you can't have it and be extensible at the same time. It's not possible. So we actually have a two different JSON schemas. one of which is relaxed, and that's the default. So you can put properties that are not defined in the spec into the JSON, SBOM. Um, Obviously, if you're a security person, you frown upon that. You don't want that behavior, but it's the only way to make JSON extensible, really. Um, Versus XML, which obviously has namespaces and all that. So unless you're using something that is not part of the core spec, you're not going to lose any information. In fact, the CycloneDX CLI can convert between JSON and XML all day long. It's no problem. We also support protobuf because we realize that not everything has to be a file. In fact, if you want to do true automation, you should never have a file. So we support protobuf as well as an official format. So you can actually store it in that way too. One thing that you might want to consider, however, is signing. So if an SBOM was actually signed, can you actually store that in your repository today in whatever native format you have and be able to return that same thing signed or not? If that's a requirement or not, but I'll just throw it out there.
And in the wild, do you see mostly tools that consume Cyclone DXS forms? Do they support different like JSON XML formats, or like do they support mostly XML, or like one or the other?
Most of them, well, uh, let's see, dependency track, my project, Sonatype's tools. I think Sonatype is mostly XML. Dependency track is both, right? We can ingest JSON all day long. Then you have other vendors like Anchor, for example, which, they've got a bunch of container stuff, some commercial, some free. They're mostly JSON, right? I don't think they do any XML today. So I think you're going to see a mix, and that's okay. We don't necessarily want to prescribe what format people should use. We want to make it as easy as possible to use whatever format is good for you, right? It becomes problematic, however, with extensibility. That's where JSON just kind of falls apart.
And is that going to be like even supported in the future? Like, if there are some shortcomings of JSON in the future, there are no like concerns about that being deprecated and XML or
No. We're actually experimenting. We've had a couple conversations with some PMs over at SNCC, and because they want to support only JSON, right? And how do we support these schemas extensions in JSON is kind of an open question. There's a number of different avenues that we can take if we want to actually validate something, and as well as not just the core spec, but that extensible stuff as well. If we want to validate the entire thing, one of the approaches we could do is we could have the CLI, the CycloneDX CLI, actually dynamically create JSON schemas based on what capabilities you actually want to validate against, right? That's one option. Another option is to have a extensions array in the JSON and just don't validate anything in there, right? You can just put whatever you want in there. The third option is to mimic the namespace support that exists in XML, try to mimic that in JSON. So there's a few different ways that we're kind of experimenting with it. All of these ways are less than ideal, right? Ideally, we would have something better than JSON schema to deal with, but we don't. And because of that, JSON with extensions in JSON format, it's always going to be a less than ideal option. We're just trying to figure out what the best approach is going to be for the greatest number of people.
I know we were running short on time. I just had one last question, like in terms of merging things. So since Buildpacks are provided by different authors and we only provide the platform, what happens when the authors provide different versions of the Cyclone DX spec and we want to merge them?
Yeah, nothing really. I mean, you can merge them as much as you want. The only requirement when you merge is that every component can have an identifier. We call it a bomb ref, and the bomb ref needs to be unique. That's really it. So just you need to make sure that bomb ref is unique, otherwise the document will fail to validate. Validation in Cyclone is fairly simple. Again, we rely on XML schema and JSON schema. We do not, unlike SPDX, where you have structural validation and business level validation, both of which are required to do document level validation. With Cyclone, it's much simpler. So we don't have that additional complexity. So you can use the CLI to validate, or you can just use XML schema and JSON schema. It's up to you.
And does the CLI currently support like merging different versions of Cyclone DX documents?
I think so. File a defect if it doesn't.
Yeah, and I think we're running out of time, but thank you so much for joining us today. And if we have any questions, I think we can. Is the Slack channel the best place to ask any further questions?
Yeah, absolutely. Feel free to reach out. If you have questions on Cyclone, where it's good, where it's not so good, let me know. Be glad to answer any questions you have. And I also encourage anyone to join the Cyclone DX Slack channel that Sam mentioned. We have a fairly good community of people there that are adopting and supporting the spec. So check it out.
Thank you so much.
Thank you.